MCEN 1131 Engineering Mechanics Statics General Definitions and Units, prepared by Mirko Dumanovic. In physics, a rigid body is a solid body in which deformation is zero or so small as to be negligible. The distance between any two given points on a rigid body remains constant over time regardless of any external forces being exerted upon it. A force is a push or a pull that acts upon an object as a result of its interaction with another object. Whenever two objects interact, they exert a force upon each other. Recall that mechanics is the study of stationary and moving objects under the action of forces. It is broken down into statics, focused on stationary bodies, dynamics, moving bodies, and strength of materials. We are surrounded by many examples from statics. Bridges, industrial chimneys held up by cables, the roofs above our home, and the chair in which we sit are all examples of statics. To fulfill the first and foremost design requirement, namely safety, we must first learn and understand the many elements of statics. Canada officially uses the SI metric system. Because the United States is our largest trading partner and neighbor, Canada also makes frequent use of the imperial system. Please review the units on the left and ensure your familiarity with each of them. The metric system was standardized in June of 1966 when the International Organization for Standardization approved the system, calling it the Le Système International des Units. The abbreviation is SI. Please review the standard naming conventions above. Mass. The mass of an object is a measure of the amount of material in that object. A base unit of 1 kilogram is used, with 1,000 kilograms equaling 1 ton. In the imperial system, it is a slug. Time. The basic unit of time is 1 second. Because of universal acceptance, other permitted units are the minute, the hour, and the day. Angle. The radian is used for measuring plane angle. In common practice, plane angles will continue to be measured in degrees. It is important to note that 360 degrees equals 2 pi radians. Force. The unit of force is the newton. 1 newton is the force applied to a mass of 1 kilogram that is required to give it an acceleration of 1 meter per second squared. The greater unit is the kilonewton, with 1,000 newtons equaling 1 kilonewton. For the imperial system, the common unit is the pound force, and the greater unit is the kip, with 1 kip equaling 1,000 pound force. Let's talk about pressure. Isaac Newton, Blaise Pascal, and Pierre Varignon decided to play a game of hide and seek. It was agreed that Newton and Pascal would hide and Varignon would be the one seeking. Pascal hid behind a tree, but Newton took a different approach. Standing where he was, he drew a 1 by 1 meter square on the ground and stood in the middle. When Varignon finished counting and turned around, he shouted, "I found Newton." Newton, however, replied, "I'm not Newton, I'm Pascal." Why did he do this? Because 1 Newton per meter squared equals 1 Pascal. For us to continue our path to understanding statics and engineering, it is necessary for us to renew certain concepts in math. You'll have one quiz relating to this in order to give you a sense of the type of examples that you should practice. Pause the video now and review the concepts on the left-hand side. Once done, try to solve the problem below. The answer to this problem will be provided in the following slide. Now try solving the system of two equations with two unknowns on the left. Answers are provided on the right. Finally, try solving the quadratic equation shown here. A step-by-step guide is provided in the space below, as well as in the following two slides. The mechanics that we study are all based on Newton's laws. To this day, we call it Newton's mechanics. Let's quickly review Newton's three laws of motion. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is normally taken as a definition of inertia. The second law explains how the velocity of an object changes when it is subjected to an external force. This law defines a force to be equal to change in momentum, mass times velocity, per change in time. The third law states that for every action, force, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal force on object A. Homework. Review the relevant topics and practice examples and problems from the textbook and from Moodle. A quiz concerning these topics will be arranged and you will be informed about it ahead of time. Problems for a textbook that you'll want to cover are those 1-1 to 1-23. Use the trigonometry formula sheet provided by the instructor.